In the misty rolling hills of Guizhou province, a quiet revolution is quietly reshaping the future of energy. Here, far from the bustling city lights and the noise of China's sprawling urban centers, something remarkable is unfolding, one that could change how the world thinks about power. Tucked away in this serene landscape, the sCO₂ power plant has come online. It's not just another facility, it represents a bold leap forward in energy generation technology, one that could have ripple effects far beyond these hills. This is the world's first commercial generator powered by supercritical carbon dioxide, or sCO₂, a cutting-edge technology that's been talked about in labs for years, but never before brought to life at this scale. For more than a century, steam turbines have been the backbone of electricity generation, driving the industrial age and lighting up our cities. But steam has its drawbacks. It's water-intensive, requires massive infrastructure, and its efficiency is ultimately limited by physics. The team at the Nuclear Power Institute of China asked a simple but profound question: what if we could do better? What if we could generate more power, using less water, in a smaller footprint, and with fewer emissions? The result is not a laboratory experiment or a prototype, but a fully operational, commercial-scale plant. It's a real-world demonstration that this technology is ready to power homes, industries, and perhaps even entire cities. The steady hum rising from Guizhou's hills is more than just the sound of machinery. It's the sound of a cleaner, more efficient, and more sustainable future. Here, innovation is quietly rewriting the rules of energy, and the world is starting to listen. To truly appreciate the innovation behind sCO₂, it helps to first understand how traditional power plants have worked for over a century. Let's start by comparing it to the classic steam turbine, a technology that has powered cities and industries since the Industrial Revolution. In these traditional plants, fuel is burned to heat water in enormous boilers, producing high-pressure steam. This steam is then channeled to spin massive turbines, which in turn generate electricity. The process is reliable and well understood, but it comes with significant drawbacks. These systems are huge, require vast amounts of water, and are often inefficient, losing a lot of energy as heat. Now, sCO₂ takes a radically different approach. Instead of relying on steam, it uses supercritical carbon dioxide, known as sCO₂, as its working fluid. This is a game changer for power generation. When CO₂ is heated and pressurized beyond a certain point, it enters a supercritical state. In this state, it's neither a typical gas nor a liquid, but a dense, energy-rich fluid that can carry heat far more efficiently than steam. This unique property allows for much more compact and powerful turbine designs. Thanks to sCO₂, turbines can be dramatically smaller and more efficient. Imagine replacing a turbine the size of a house with one that could fit on a desk, all while producing the same amount of power, or even more. This leap in size reduction doesn't just save space, it also slashes construction and maintenance costs, and makes it possible to install power plants in places that were previously unimaginable. The sCO₂ cycle, known as the Brayton cycle, is also more streamlined than the old steam-based Rankine cycle. It recycles its working fluid with far less energy loss, making the entire process more sustainable and cost-effective. So, this isn't just a simple upgrade to existing technology. It's a complete shift to a cleaner, more efficient, and truly 21st century way of generating power. So, what is supercritical carbon dioxide? Beyond a certain temperature and pressure, CO₂ becomes a supercritical fluid, neither liquid nor gas, but with the best properties of both. It's dense like a liquid, carrying lots of energy, but flows easily like a gas. This means less energy lost to friction and higher efficiency in power generation. Supercritical CO₂ lets engineers design cycles that squeeze more electricity from every bit of heat. It's a perfect example of physics unlocking new technology. By harnessing sCO₂, we're building a smarter, more effective way to power our world. sCO₂'s excitement comes from 4 key advantages that set this technology apart from traditional energy systems. These advantages are not just incremental improvements, they represent a fundamental shift in how we think about power generation and sustainability. First, efficiency. Supercritical CO₂, or sCO₂, cycles can reach or even exceed 50% efficiency. This is a significant leap over conventional steam cycles, which typically max out around 40%. Higher efficiency means more electricity is generated from the same amount of fuel, reducing waste and maximizing output. This breakthrough could transform the economics of power plants, making them more competitive and sustainable. Second, compactness. sCO₂ turbines and their components are much smaller and lighter than traditional steam turbines. This compact design leads to lower construction and maintenance costs, faster installation, and the ability to fit power plants into tighter spaces. It also opens up new possibilities for distributed energy, where smaller plants can be built closer to where power is needed. Third, cleaner energy. Because sCO₂ cycles are more efficient, they burn less fuel for the same amount of power, resulting in fewer emissions. This means cleaner air, less pollution, and a smaller carbon footprint for every kilowatt-hour produced. Cleaner energy is essential for public health and for meeting strict environmental regulations. These improvements directly support global climate goals and align with China's ambitious push for carbon neutrality. By reducing emissions and increasing efficiency, sCO₂ technology helps countries meet their international commitments and transition to a greener future. Fourth, adaptability. sCO₂ systems are incredibly versatile. They can harness heat from a wide range of sources, including nuclear reactors, solar thermal plants, and even industrial waste heat. This flexibility allows them to be integrated into existing infrastructure or paired with emerging technologies. Whether it's next-generation nuclear reactors, expansive solar farms, or modern factories looking to recycle waste heat, sCO₂ can be paired seamlessly, making it a truly universal solution for diverse energy needs. This remarkable versatility could fundamentally reshape energy systems around the world, enabling a more flexible, efficient, and sustainable approach to power generation. Supercritical CO₂ isn't just a technological upgrade, it's a key to building a more resilient, integrated, and sustainable energy grid for the future. sCO₂'s grid connection is a global milestone. While many nations researched sCO₂, China is first to make it work at commercial scale. This positions China as a leader in next-gen energy, setting a blueprint for others. The project proves sCO₂ is not just theory, it's practical and reliable. Now other countries can invest with confidence, accelerating global adoption. sCO₂ is a beacon, showing we can break free from old limits. It's proof that bold engineering can change our energy future. The sCO₂ plant opens a new chapter for energy and the environment. More efficient, cheaper, and cleaner plants are now possible. As sCO₂ spreads, we'll see faster progress away from polluting energy sources. Imagine factories and solar farms using sCO₂ to turn waste heat and sunlight into reliable power. The journey is just beginning. Ongoing research will make this tech even better and more affordable. Each new plant will teach us more, driving further innovation. This is the next leap in humanity's energy story. Smarter, cleaner, and more sustainable. The quiet revolution in Guizhou is just the start of our greener tomorrow.